talk about these projects. 122 and 123, I think is what I'm doing. Yeah, 122 and 123. All right. So 122 is just looking at the PE headers. I'm going to drag this to the side so I can see the instructions while I demonstrate it here. There, all right. So we're going to make a program, and we're going to use Visual Studio. So I start, and a V for Visual Studio, which is here. And the instructions say 2017, but we're using 2019 if you're using my pre-made machine. The instructions are from an older machine. And now you want x86 native tools command prompt, which is here. You have to get the right command prompt or it won't work. And I'll make the font bigger. Okay. It is one of the many weird things about Microsoft. You have to launch the command prompt in that strange way or it won't work. So now I'm going to make a directory to put it in, and then go into that directory, and then notepad hello.cpp. All right, and create a file. And I wonder if I have to copy the code. Now I can just type it. There's not that much. Okay. So pound include iostream. That's the C++ to, let me just make the font bigger. That's the C++ to include a library to print and such. Then using namespace. I always say this in C++. I don't really remember why. Now void main. Printf. And I'd like a carriage return. All right. And that's it. That's about the simplest hello world you can make. So I'll save that. And close that. And now compile it. There were some switches here. I don't even think we need them. We can just compile hello. All right, and there's the Microsoft compiler, compiling and linking. So now if I do a dir, I'll see that I wrote the CPP, it compiled to make object code, and then it linked it to make hello.exe. So I can run the glorious hello.exe, and it says hello. So about the simplest program you could ask for, and we're just going to analyze how it looks. So we're going to look at that thing in PE view. All right, and so we're going to go to C, PE, hello. All right, and I'm going to make the font bigger again. Font. All right, so here you have the various sections. It's got text, our data, data, and relocation. And so at the very start, we look at the MS-DOS header. We have the signature, which is MZ, and this is all a useless appendix for MS-DOS programs that are not used anymore. Instead, it uses the new exe header down here. That's the MS-DOS stub program that just tells it you cannot run this thing in DOS mode, and tells you to use, which tells the operating system to run it in using portable executable instead, the PE header. And that's down here. The signature is PE. And if I put it this way, there I see it starts with PE 5045, and then it has a lot of binary stuff that's not readable. And here's what it is: things like the time, date, stamp, and so on. So that's the image file header. Now the image optional header has a lot of important information in it. It's got the image base here, which is where it tries to load, and executables always try to load at 400,000 hex. Then the size of the image is that size of code, and here's size of image. This is the total size of all sections when loaded in memory, which is why it's a little bigger than the size of the code because when it loads into memory, it puts gaps between the sections that are just rammed together on the disk. So this is how big it's going to be in memory, 1C1000. And the import table is down here. RVA is the relative virtual address, which is the location of the import table relative to the base table of the image. So that's how you can find things. And if you go to the import address section, we've seen that. All right, this is, all right, you know how this works. Then we see the section headers for each section. Like text, you've got the name, which by the way is limited to 8 bytes in the old MS-DOS standard. And then virtual size is the total size of this section when loaded in memory. Here's the relative virtual address, which is where it will be loaded in memory, which you'll see is always ending in thousands. Text starts at 1,000, our data starts at 12,000, data starts at 19,000, and relocation starts at 1B1000. That's why I say it gets bigger when you load it in memory. The sections are all rammed together in the disk, but it loads this one, and loads this one, and loads this one, and it leaves gaps in between them to fill them out to the even 1,000 when loading in memory. All right. And so you can actually calculate the memory layout and view it in a live memory map. So let's take a look at the memory map. You can calculate it from the header, but it's easier to just see it in Ollie debug. So if you run this program in Ollie, all right, and you load it with open, and I go to CPE, and I load hello. Then it loads, and it stops right at the start, and now I can view memory. And see, here it is loaded. Notice it is not loaded at 400,000. It's loaded at some other address because of address space layout randomization. Remember, it has a relocation section, so it relocates randomly every time I run it. All right? And so, all right, and so that's all I wanted to show you on this one. There's some challenges here where you have to find some things by comparing analyzing various files with PE view, but that's all there is to 122. And let me stop this video and make a separate video for the next one.